Scientists thought they understood how planets formed until they found TOY 849b. This rocky behemoth is 40 times Earth's mass, yet it orbits so close to its star that a year lasts just 18 hours. Is it the exposed core of a gas giant? And what ripped away its atmosphere? From rogue planets to worlds with two suns, these discoveries are rewriting the rules of astronomy. Let's explore the most baffling exoplanets ever found. TOY 849. Shouldn't exist according to what we know about planets. It's a massive rocky world, 40 times heavier than Earth, but it orbits its star closer than Mercury orbits our Sun. A full year there passes in just 18 hours. This creates temperatures hot enough to melt rock. Normally, a planet this size would be a gas giant like Jupiter with a thick atmosphere. But TOY 849b has almost no atmosphere at all. Scientists found this planet using two methods. The transit method detected its shadow as it passed in front of its star. The radial velocity method measured how the planet's gravity makes the star wobble. Together, these showed its mass and size, revealing its extremely high density. This density matches what we'd expect from a planet's core, not a complete planet. There are two main theories about how TOY 849b ended up this way. The first suggests it was once a gas giant whose atmosphere got torn away. Its close orbit means the star's gravity and intense heat could have stripped the gases over time. The second theory says it might have never formed an atmosphere at all. Perhaps collisions with other objects during its formation prevented gas from accumulating. Recent studies favor the first explanation. The planet's composition matches what computer models predict for the exposed core of a gas giant. Elements like iron and silicon appear in amounts expected at a planet's center. This makes TOY 849b the first confirmed example of a planetary core we can study directly. What's surprising is how rare this seems to be. Out of thousands of known exoplanets, we've found very few like TOY 849b. This suggests whatever process stripped its atmosphere was unusual. Some researchers think a catastrophic collision with another massive object might have blasted away its gases. Others propose the star's intense radiation slowly eroded the atmosphere over billions of years. The planet's discovery changes how we think about planetary evolution. It shows gas giants can lose their atmospheres completely under extreme conditions. This raises questions about whether other exposed cores might exist in different solar systems. Future telescopes could search for more examples to test these theories. TOY 849b gives us a unique window into planetary interiors. On Earth, we can only study cores indirectly through seismic waves. Here we have an actual core exposed in space, letting us examine its composition directly. This could help us understand how all planets, including Earth, formed and evolved. But as strange as TOY 849b is, it's not the only exoplanet breaking the rules. Some worlds have weather patterns that make Earth's most extreme storms look calm by comparison. WASP 76b shows how extreme exoplanet weather can get. This gas giant orbits so close to its star that one side always faces the heat. The day side reaches 2,400 degrees Celsius, hot enough to vaporize metals. At night, temperatures drop by about 1,000 degrees. This extreme difference creates winds that carry vaporized iron from the hot side to the cooler side. When the iron condenses, it falls as molten rain. Scientists detected this iron rain using spectroscopy. They found iron vapor in the planet's atmosphere when the day side was visible. When the night side came into view, the iron signal disappeared. This suggests the iron condenses into liquid droplets that fall out of the atmosphere. The process resembles Earth's water cycle, but with iron instead of water. The planet is tidally locked, meaning one side always faces the star. This creates permanent day and night sides. The temperature difference drives strong winds that redistribute heat across the planet. These winds may reach speeds of several kilometers per second. The iron rain likely falls mostly near the boundary between day and night, where temperatures drop sharply. While WASP-76b has extreme weather, TRES-2b has an entirely different mystery. This planet reflects less than 1% of the light that hits it, making it darker than coal. Even though it orbits close to its star, it appears almost completely black. Most planets reflect at least some light, but TRES-2b absorbs nearly all of it. Astronomers first noticed TRES-2b's darkness when they measured how much light disappeared as it passed behind its star. The amount was almost zero. Further observations confirmed it reflects almost no light. The planet does glow faintly red from its own heat, but this is very dim compared to the starlight it absorbs. Several theories attempt to explain TRES-2b's darkness. One suggests its atmosphere contains light-absorbing chemicals, like vaporized sodium or potassium. Another proposes it lacks reflective clouds that most hot Jupiters have. The planet's high temperature might prevent cloud formation, leaving only dark gases in its atmosphere. The darkness might also come from an unknown material in the atmosphere. Some researchers speculate about exotic compounds that absorb visible light extremely well. Whatever the cause, TRES-2b shows that planets can be much darker than we previously thought possible. These two planets demonstrate how diverse exoplanet atmospheres can be. One has vaporized metal that falls as rain, while another absorbs almost all light that reaches it. Both challenge our assumptions about what planetary atmospheres should look like. They show that conditions we consider extreme might be common on other worlds. While some planets are incredibly dark, others are surprisingly light, not in terms of color, but in terms of density. Some exoplanets have such low density that scientists compare them to cotton candy. WASP-193b defies expectations for what a gas giant should be. Most planets of its size have densities similar to Jupiter or Saturn, but this one has the density of cotton candy. Measurements show it's about 1,200 light-years from Earth, and nearly 50% larger than Jupiter, yet only about 15% as massive. This makes it one of the least dense planets ever discovered. Scientists found WASP-193b using the transit method. As it passed in front of its star, they measured how much the starlight dimmed. This revealed the planet's size. Then they used the radial velocity method to measure how much the star wobbled due to the planet's gravity, which gave its mass. Combining these showed its extremely low density. Several theories try to explain why WASP-193b is so puffy. One suggests intense heat from its star has inflated the atmosphere. The planet orbits very close to its star, completing a full orbit in just over 6 days. This proximity keeps its atmosphere hot and expanded. Another theory proposes the planet formed differently than typical gas giants, perhaps accumulating lighter materials that didn't compress as much. The most puzzling aspect is how the planet maintains its structure. Normally, gas giants have enough gravity to compress their atmospheres into denser layers. WASP-193b's gravity seems too weak to do this effectively. Some researchers think internal heat sources might help maintain its inflated state. Others suggest we might be seeing the planet at a special point in its evolution where it's temporarily puffed up before eventually contracting. While WASP-193b orbits a star, some planets don't belong to any solar system. ACE-IM PJ01365663 plus 0933473 is one such rogue planet, drifting alone through space. What makes it special is its incredibly strong magnetic field, about 4 million times more powerful than Earth's. This creates spectacular auroras, even though there's no star to provide solar wind. Scientists detected this planet's magnetic field through radio emissions. These emissions come from charged particles moving along magnetic field lines, similar to how Earth's auroras form. The difference is, this planet generates its own particles through internal processes rather than receiving them from a star. The planet's strong magnetic field likely comes from its rapid rotation and internal heat. It spins once every 2 hours, much faster than Earth. This rotation, combined with a hot interior, may drive a dynamo effect that creates the powerful field. The planet is also quite young, which means it retains heat from its formation. These two planets show extremes of planetary diversity. One is so light it resembles cotton candy, while another generates its own spectacular light shows without a star. Both challenge our understanding of how planets form and behave. They suggest the universe contains many more planetary oddities waiting to be discovered. These discoveries prove that planets can exist in forms we never imagined. From inflated gas giants to magnetic rogue worlds, each new finding expands our knowledge of what's possible in the cosmos. The more we look, the more we realize how much we still have to learn about planetary formation and evolution. These exoplanets show how much we still don't understand about the universe. From exposed planetary cores to worlds with iron rain, each discovery challenges our ideas about how planets form and behave. Scientists are constantly updating theories to explain these bizarre worlds. Which exoplanet surprised you the most? Was it the cotton candy planet or the rogue world with powerful auroras? Let us know in the comments what you think might be the strangest planet out there. New telescopes will likely find even weirder worlds in coming years. As technology improves, we'll keep uncovering more cosmic mysteries that rewrite the rules of planetary science.